now rectangular beam, okay. Now if I ask you, can you calculate the section modulus of I beam as quickly as possible? What's now um, the best way to do is using the parallel axis theorem in this one. So if I take this neutral axis, right? Let's say depth of the beam is d. You can write this thing because I'm doing that in on the rough sheet, and I will I have not added that in notes, so I might miss it. So this is the, let me just what I do, because you will miss this. I will just add that in the note as well. I will add it. Don't worry. Okay. Okay. So now I is this is my B, and my thickness is T. Suppose both. Okay. Try to give same thickness to the top and bottom line. Don't go in like office. Okay, I will give 10 mm at the top and I will give 20 at the bottom. No, don't keep it same. Nobody is giving you parambit chakra for giving reducing the thickness. Okay. So T thickness are there, B. Okay. Now simple, your second moment of area would be, suppose this is the area I have A. Focus only on flanges, top flange and bottom flange. Don't see web, just remove the web. Why need to remove the web? Because your it would be having very less section. Okay. So you take the I as A time d by 2 square into 2, right? Because this is your area A, this is d by 2. You calculate this and you make it twice because 1 and 2. Okay. So this is simple B into T d square by 2. Okay. You use this formula for I, and if I go for the section modulus of the I section, then it would be B into T d square by 2 times d by 2 b t times t. Simple. So now you want to calculate section modulus, it would be you multiply everything d b t. That's it. Okay. As quickly as that is, it's a simple way to do it. And the same thing, if someone asks you, okay, I have the truss with me and I have one I section at the top chord, I have one I section at the bottom chord, right? This is truss, bottom chord, and this is top chord. Okay. And this is my depth d. Okay. Now what do you think, how we can calculate that?
Top chord, bottom chord is multiplied by 2.
You will calculate the, no, you will calculate about the for I section or not? I won't calculate. Now I will see the section properties table. I will see the area of this A1. I will see area of this A2. I will take A1 d by 2 square plus A2 d by 2 square. Sorted. That's it. Try to simplify. No much. You don't have to write piece of calculations just to show that you, okay. So this will this shows that, and you can write that as assumed flanges is responsible for resisting bending moments. Yeah, and this way you can calculate for any of the any, if you see, if even if we get this box beam, right, this is easy to do because you can subtract the first box minus outer box is easy. But if you don't, if you get some random shapes, then you just take this top flange, bottom flange, that's it. For the web, you take the web. For the shear, you don't take the area of this, you take only this one, web ones. Okay, this is the principal rule for all the section properties. So you only need to remember BD cubed by 12 and this parallel axis theorem. That's it, these two things.